obviously you can't defend your worldview, which is
Yes,
what
I
you're up here
can.
supposed to be doing, and now you're trying to deflect it to my
I
worldview. Is that
I
the case?
have I can make you prove that we have the evidence that evolution occurred.
You're up here to prove your idea of how we got here. Okay. I'm not up here. I'm
Okay, I
questioning
will just tell
your
everybody
statement.
because you will not engage in this. So, for example,
I'm trying to
if there were
engage. You're
two
deflecting.
canines on the ark, we have multiple different species of canine today. Wolves and foxes, I can't remember which way it goes, but one of them has twice as many chromosomes as the other one does. Okay. Do you think that new proteins are found in one of those species versus the other?
I think wolves and foxes are different.
Yes. And they are the descendants of a singular canine kind that was on that ark.
How do you know that?
So, how many canines were on the ark?
I just said earlier, I don't know. You're trying to force me a position because you can't defend yours.
No, no, your position is literally a contradiction. How many frogs do you
I
think were
never
on the
took a
ark?
position. I'm taking the negative.
How many frogs do you think
You're,
were on the ark?
you can't defend your position, so you're
Yes, I
forcing me to
can.
have one.
What I'm doing first is
You're
proving
deflecting.
that according to your criticisms of the traditional model, according to what can't happen, which falsifies the traditional model, your beliefs about the world have to be false. I'll just make
I
this really
want
simple because, again, you refuse to commit to a position because you refuse to make your views subject to any kind of scrutiny, which is insanely dishonest, but I'll just let you
is
do
that what
that.
you're
But I'll
doing?
explain how this works for everybody. No, not every single living kind of thing needed to be on the ark. I doubt the ark had an aquarium. It obviously didn't exist, but we're just granting this. It doesn't matter because either way, that ark is only going to house a few thousand species at best. And what happened from that is at least many hundreds of thousands of species came about from it in literally in such an extremely short amount of time. It's been 4,000 years since then, but we haven't been gradually gaining species every single day. If that was the case, it would be scientifically known. Excuse me, I had to burp there. So, we can look at simple examples like the fact that there are 50 different families, which is what creationists call a kind in general. There are 50 different families of frogs alone. So the evolution of this idea that something always produces after its kind has to be false according to the creationist worldview. It absolutely has to be false. And then, like with the canines, with the tremendous differences in chromosome numbers, but whatever, it doesn't matter. You're having thousands of species at the most turn into hundreds of thousands of species. So some kind of event like a new kind of protein coming up absolutely has to occur for a tiny number of species becoming hundreds of thousands of species. So we got that out of the way. What do you want to know? Do you want me to tell you what the evidence of evolution is?
Yeah.
Okay, if evolution were true, what would the evidence look like?
You'd see new proteins forming with novel functions.
That's the
We
only thing you
should
can
say that that's
imagine.
just happened.
That is the only thing you can imagine.
New genetic sequences form to form new, DNA gives code for proteins. So yeah,
Well,
novel proteins, novel functions.
we certainly have direct evidence of that.
In what
What about a
case?
change in
Humans
phylum? Is
have
that even
multiple
possible?
copies of several genes.
So
So that's exactly the thing you're asking for. We could also look at, do you know what Hox genes
multiple
do?
copies of several genes. What is new? What is a new protein there? Like what's going on?
You didn't say new protein. You said like added
Novel
duplicated
protein,
DNA.
novel function. That's what
That
I
was
said.
one of the things you said. The other thing you said was like duplications or added information to the genome or whatever.
I never
Do you know
said
what
that.
Hox? Yes, you did. Do you know what Hox
No, I
genes are?
didn't. Duplications would not be new proteins with new functions.
Do you know what Hox genes are?
Are those Hmm. I've heard of them before.
They're genes that
I can't
control
recall.
for the development of the body. So like
Right.
you can transpose a section of, like, you can take an embryo and you can cut off a piece of tissue where the Hox genes that control the development of a limb are happening, and you can patch that piece of tissue onto like its backside, and it'll grow a leg out of that part of its body. Wild experiments with Hox genes have been performed. So,
Right. Yeah, they're yeah, the Hox genes I recall now.
yep,
They're like the body layout. They control like the body
yes,
layout in animals.
yes. So,
Right.
um, for example, insects are a type of arthropod. They have
Mhm.
three pairs of legs. Crustaceans are a type of arthropod that have five sets of legs. Myriapods, like millipedes and centipedes, have multiple of them. What we find is, okay, we have a body plan, the arthropod, but they have the same generic body plan, but they express it differently. What we find is duplications of those Hox genes, and then differences in how long those Hox genes are active for during development. So the kind of thing that produces additional structures is known about in science.
Okay. That's still not new proteins or new functions.
Okay, let me see. I don't want to read through my book here because that would just take forever and we'd be sitting in silence. So give me a second here.
And while we do that, why don't we just consider, after the flood, with a radically altered environment, geographic isolation, right, ecological niches to fill, maybe the original kinds diversified rapidly within centuries. I mean, I think they've been able to spot that in wolves.
Taylor, feel free to respond to that while I try to look for something here.
Um, yeah, I think that yeah, I think that we won't know exactly how many of each species was, on the ark. I don't claim to. So,
Yeah, yeah, I don't think it's specifically stated.
Yeah, well, we can know what the upper limit would be.
Yeah, I think, yeah, analysis has been done. I think I read it was 2,000 to 7,000.
Mm-hmm. Taylor, do you know about type 3 secretory proteins and how they are remarkably similar to the bacterial flagella protein structure?
yeah, I've heard about that.
Okay, so is your claim that that doesn't count because nobody saw it happen, even though the evidence of it happening is predictable and has been found?
Yeah, I would like to see like, it actually happen. And things like the Linsky experiment where they're like speeding up the evolutionary timeline through like exponential growth of these bacteria.
Mm-hmm.
Well, I can ask you a different question. Like, how do you think in general, like the DNA code came about? Would you classify that in like abiogenesis or evolution?
Well, it can be literally both. Evolution, um, as in just change over time, or even natural selection, um, the chemical environment that would have produced nucleic acids, perhaps autocatalytic ones, like an RNA world first world or a metabolism first world, natural selection would have been happening. We've created like synthetic molecules and seen them be able to compete against each other. You can do this like with amyloids, I believe, in the lab. So we have I don't know what you would call them, like analogs or whatever, in labs that demonstrate in principle that this kind of thing can happen.
So how do you think like new chromosomes and like how do you think like do you think
Genes
like
get duplicated all the time. We know that this
right.
happens.
Okay. So like with these like duplications, do you think like a point mutation or like multiple point mutations would be enough to like get new proteins?
Well, a point mutation could result in a new amino acid, which could theoretically produce a new protein.
Right. Yeah, it'd just be nice if we saw like that happen because it seems like what we're observing is like, you know, like translocations. We can also see like bacteria switching out their DNA, but like fundamentally it seems like the same functions are still present in like these types of experiments.
Hmm.
And a lot of it's like epigenetics too, like adapting to your environment, like turning on and off genes that are already present. So, gaining this like this new, DNA that would produce like, novel proteins with novel functions would kind of be really key in showing it. But, if you want to get back with me on that, that's fine.